Hello guys, in this video we will be looking at another Gen AI application which is sort of a home project but looks quite promising. The application this time is LLM Flex. This application is meant to be a full-blown Python application for developing AI applications with local LLMs. There are a lot of good features which are embedded in this application. For example, it allows the Python developers to work with different LLMs and do prompt engineering with a simple interface. It favors free and local resources instead of using paid APIs to develop truly local and private AI powered solutions. It provides classes to load LLM models, embedding models, and vector databases to create LLM powered applications with your own prompt engineering and RAG techniques. With a one liner command, you can load a chatbot interface to chat with the LLM or serve a model as OpenAI API as well. In this video, we will be installing it locally and then we will play around with it, and I will drop the link to its GitHub repo in video's description too. Before I do that, let me give a huge thank you to Mass Compute who are sponsoring the VM and GPU which I am going to use for this video. If you are looking to rent a GPU on affordable prices, I will drop the link to their website in video's description, where I will also put a coupon code which will give you 50% discount on a range of GPUs. Let me quickly show you the VM. This is a VM which I'm going to use, Ubuntu 22.04, and the GPU card is this NVIDIA RTX A6000 with 48 GB of VRAM. Okay, so let's first create a Conda environment. If you don't know what Conda is, I already have done heaps of videos on it, so please check it out. Let me clear the screen and let me create a Conda virtual environment, which I'm just calling as LLM Flex, and that is going to keep everything separate from my local installation. Let's activate that, and you can see that in parentheses. Let's clear the screen. Now there are few prerequisites which you need to install first. Make sure that you have PyTorch installed. So I'm just installing the PyTorch from source as per my own operating system version. This just takes few seconds if it is not already installed. So let's wait for it to finish. Torch is installed. Let's also install Llama CPP Python, which is a Python wrapper on this Llama CPP for local inference with LLMs. That is almost done. That is also done. Let's also install transformers and Hugging Face Hub. That should be done fairly quickly. It's not that huge. And all the prerequisites are done now. Now, in order to install this LLM Flex, all you need to do is to do just pip install LLM Flex, and that is going to download it, install it. Let's wait for it to get finished. And that is all done. Let's clear the screen. Let me launch my Python interpreter, and then let's import first this LLM factory from LLM Flex. And now let's specify our model. You can use any model from Hugging Face in GGUF format. I'm just going to go with this one, the OpenHubs from the blog. And now let's instantiate the LLM. So I'm just calling this model function, and then I'm just calling temperature 2.7, which mentions the creativity of the responses, and then max new tokens. And it is going to first download the model. Let's wait for it to finish. The size is just over 3 gig. And the model is downloaded, and it just seems like Llama CPP Python output to me. Okay, so that is good. Let me press enter a few times. And now let's specify your prompt. I'm just asking it what is the color of an apple, and then the answer. And then let's invoke that LLM with that prompt, and I'm simply using this LLM.invoke function. And it has taken a bit of a time and has returned the response. Let's print it. There you go. It says red, although it can also be green. And then another question, and then all the answer from the LLM. But the main part is that this is how easy it is to do local inference with this LLM factory. But this tool is not just about inference. Let's check out few other examples. Let me clear the screen here. You can even use this tool with the vector databases and with the embeddings. If you don't know what embedding and vector database is, embedding is just a numerical representation of your text, and vector databases store these embeddings. Embeddings are also called as vectors. Normally, this is used in the RAG or retrieval augmented generation when you want to provide more context to the large language models as per your own data. I have done heaps of videos on the channel. So if you want to learn more, please check the channel out. Now for that, let me grab an embedding model. So again, I'm just grabbing this Hugging Face embedding toolkit and this GTE small embedding model. You can just grab any one of your own. These embedding models are normally very small. Okay, let's create a vector database. And for that, I'm just giving some food items. Let's create the sort of in-memory vector database with FICE. And this is a quite a famous vector database. That is done. And now let's do the semantic search on the vector database. Semantic search means that, for example, we are asking it here beef. It is going to go into this food item and see which one is more similar. So it has returned us this vector database research this, and it has found it here. You can also print out the numerical representation and all that stuff which you want to do here. And then if you go here and print simple vector db, then it is going to return you the memory address of it. You can also use few of the browser tools with it. For example, there is author of this tool, let me clear the screen, has implemented a browser tool with DuckDuckGo for browser research. So for example, you just import browser tool and this flash ranker. You can create a ranker function here which ranks the embeddings. So this is a ranker it is using behind the scene. And then for creating the browser tool with the embedding toolkit which we created earlier, all you can do is this. And then you can run the tool by simply using, for example, something like this search query, and it is going to search it, and it is just telling you how to install Python, like open the Microsoft Store and all that stuff. And you can ask it anything, like whatever you want to search with it. Like for example, you can, let me clear the screen maybe, and it'll be easier to read. For example, here you can just say that uh, who is Fahad Mirza, and then you can just search with it, and it is going to search the net with DuckDuckGo browser. So primarily the aim here is to make the things as easy as possible. So you can ignore this. So what happens is that sometime DuckDuckGo is not able to find that, or there's a timeout on it. So this is a system issue, not the tool issue. Anyway, so I'll just give it a time. We'll move on, and then we might try it again so that it won't time out again. Now, another cool thing about it is that you can also use the one-shot React agent to go through more complicated workflows. So you can import that agent from here. You can use the prompt template from the model, but you would have to define this with the tool and this LLM which we defined earlier. And then you can even run your agents quite easily by just like I'm just running the agent with this web search. Hopefully it won't time out due to my DuckDuckGo, but let's see. And then it is running, it is generating something. And as I mentioned, you can do a lot of stuff here, but it all comes out of the package. And make sure that you have opened your internet connectivity for this. And the agent has started printing the response. You see that this is a thought of agent that I need to search for GenAI, and then it is just going through the loop, and then it is searching it. It has downloaded some of the data, and then it is still thinking that the 10 biggest generative AI trends for 2024 must be ready. And you see, I haven't set any API. All it is using is the local LLM and local tooling. So looks really good. I will let it search. So all in all, I think quite a promising tool. One suggestion I would have for the researcher is to integrate it with OLama instead of Llama CPP. That will not only make it more responsive, but also it is easier to load, and then the response time will be really good for it. Other than that, really awesome effort. I will drop the link to this GitHub repo in video's description. If you like the content, please consider subscribing to the channel. And if you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.